Hi guys, in today's lesson we're going to discuss a question from H2 Physics under the topic of kinematics. This question comes from prelim paper for ACJC Paper 2 in 2022. Okay, let's take a look at this question. Right, okay, I've got a man who wants to knock down a coconut from a tree by throwing a stone, shown in the figure. Right, so we're going to draw the parabolic path, in this case over here. Right, okay, coconut is 80 meters above ground. The hand is 2.2 meters above ground, releases the stone at the initial velocity of 20 meters per second. Okay, put the information in, 20 meters per second. And therefore I've got an angle over here. Okay, I'm going to call it theta. And I'm going to set the direction, okay, upward as positive and to the left, from left to right as positive. I'm going to set the direction so that we can do the computation later. Okay, for part one, we're going to assume, right, okay, the air resistance is negligible, right, so there's no air resistance involved. Explain qualitatively in terms of acceleration and velocity why the path taken by the stone is parabolic. Right, in this case over here, I've got two components. Okay, one is the vertical component and one is the horizontal component. Okay, the horizontal component is actually constant throughout. Right, so in this case, the horizontal component is actually 20 cosine theta, right, which is constant throughout over here. Your vertical component, 20 sine theta, is affected by G. G is acting downwards. All right, so in this case, my G will be minus 9.81. And therefore, I will have a parabolic path because one of the component has an acceleration due to gravity. All right, okay, so in this case over here, we're going to just write down this part. Okay, horizontal velocity, right, is constant. Okay, whilst the vertical velocity, okay, experiences, okay, an acceleration, a constant acceleration. Okay, of G. And in this case, your G would be 9.81 meters per second square. All right, okay, so that's for part one. Okay, for part two, you're asked to show that the angle at which the stone should be released from the horizontal so that it will hit the coconut. Okay, and this angle is 62 degrees. All right, so I'm going to make use of the vertical component, because the vertical component basically changes and is affected by acceleration due to gravity. Right, so in this case, I'm going to let, right, okay, I'm going to write the answer here, over here. Let the angle, okay, be theta. Right, so your V, the Y component, right, is actually 20 sine theta, and your X component is 20 cosine theta. Right, in this case over here, because I only have height that's given to me, so therefore, right, I'm going to use, right, the V square is equals to U square plus 2AS, this relationship to help me find out what's theta. As I have over here, A I have, right, U is the initial velocity. Okay, final velocity in this case will be 0, right, when it hits the coconut. Right, in this case over here, I will have 0 equals to, okay, 20, okay, I'm going to use this part over here, 20 sine theta bracket square plus 2, a will be minus 9.81. Right, because we have already set the direction. Okay, positive is upwards, therefore g is acting downwards, and I have to add a minus sign there. Right, the height is actually not 18 meters. Right, so you can take this height that is measured from the level of the ball, or the hand rather. Right, so this part over here is 2.2, and therefore this part is actually 18 minus 2.2, which gives you 15.8. Right, so I'm going to put 15.8 over here. 15.8. Right, then from there you will work out, right, your theta from here. You just do an expansion, right? Okay, this is 0, right? So I've got 400 sine square theta, right, equals to 9.81 times what? 15.8. You can work out. Okay, you should get theta to be what? 61.682, which is approximately 62 degrees. Right, and this is the part that they ask you to prove. All right, so this is actually for part 2, right, in this case over here. Right, for part 3, you are asked to calculate the time taken for the stone to reach the maximum height, okay, when projected at the angle. Right, so back to this diagram again. Let's see over here if I can copy the diagram over here. Okay, so that you can refer to the diagram. Right, so at the height of the maximum height, which is about this level here, right? Okay, because it's a parabolic path, the maximum height will have 0 velocity at the top of the path. All right, in this case over here, I'm going to set this as 0. Vy, right, is equals to 0 at the maximum height. Maximum height in this case over here. Right, therefore I'm going to put this part over here, right, using what? Again, using, I need to find out what is my time, right? So now I'm going to use an equation that involves time, right? So I'm going to use V is equals to what? V is equals to U plus AT, right? Okay, so my Vy is 0. Okay, 0 equals to 20, right? 20 sine, okay, using the angle that we found earlier, right? So be using the angle, right? Okay, that is about 61.682 degrees. Right, make sure you use the angle that has got more decimal places, right, so that you will not be affected by rounding error. Right, plus minus 9.81 t, and from there we'll calculate our time, right, and my time calculated will be 1.80 seconds. Right, so make sure you understand which equation to use depending on what variables have been given to you. And it's best to put the information into the diagram so that you can see the connections between the variables very clearly from here. Right, so this is actually the first part. Okay, I hope that you have learned something useful from the kinematics question. Okay, I'll see you in the next lesson.